Hi everyone, my name is Lena and this is my week 2 presentation for NPA 560. In overview, I'm going to briefly describe my new selected program for this week, identify the problem, and share 3 variables in detail. So the program that I selected, which I now realize is not actually a program, it's a funding source, but originally it was the Center for Drug Policy and Prevention. It's a 3-year program run by the University of Baltimore, and they provide training to community resources in Maryland, basically to improve the service that they're giving to drug users, and in hopes of reducing drug-related deaths, opioid-related deaths. But again, like I said, they're a funding source because they're not actually working directly with the individuals suffering from the problem. They're not working with the drug users. So next week, this will change. So the problem as I had listed it was, in the first 2 quarters of 2021, there were 1,217 opioid-related fatal overdoses in Maryland. And then of those, I broke down by race. And then of those, I ended up breaking down by age. And then of those, I broke down by gender. And I'm going to scratch all this because I'm changing it next week. And those were the resources that I used to actually find those stats. So variable 1, which I probably will keep because I'm still going to stick with the opioid-related fatalities. So that is my variable 1. That is my dependent variable. It's on a nominal scale because it has categories. And I'm not going to use these categories. I realize now that these categories are their own variables. So for categories specifically for opioid-related fatalities, I'm going to go with defining the opioid-related fatalities. Like, what does that look like? So, DOA, dead on arrival. Maybe they were not, deceased on arrival, but then within so many hours or so many days within being in the hospital, the individual passed. So that would still count. So I'm gonna break the categories down on that as it relates directly to opioid-related fatalities. Variable 2 is going to get scratched altogether because this really specifically matches the university's program. But again, their program was to provide training hours to community drug resources. And looking at it is an independent variable. It is on a nominal scale, but it doesn't work with my dependent variable because it's just too far off. Because between the training, then you got to assume, something else happened and something else happened that actually ended up reducing the number of deaths. So it's too far removed from my dependent variable. So this is not a good example, everybody. Variable 3, administration of Narcan, naloxone. So this was my confounding variable for, the presentation as I originally created it. And it does work as a confounding variable. It's on a nominal scale. And the categories are going to be like stats for numbers of administration, some type of record keeping, how many doses did paramedics give? How many doses did hospitals give? How many doses were given? I originally put in there that I was going to also record like how many doses were distributed. But again, that's getting a little bit removed because even though it was distributed, we don't know if it was used. And so we need to really look at how many doses were used to know that it's actually, to see if it's actually being effective. So in summary, I made a lot of mistakes and I hope you guys learned from them. Basically, I identified my problem though, which is going to be opioid-related fatalities. And I am going to stick with a variable related to the Narcan administration. And I'm going to come up with another independent variable or confounding variable if I make that my independent. And I'm going to kind of hone in on, for my dependent variable, I'm going to hone in on my categories so that they actually directly relate to the variable. So I hope you guys learned something from that. Thank you for your time, and God bless.